Hello, everyone. Thank you for joining us in the next series in doing data right. So before we get into some of the great content that we've got for you today, we've just got to run through some quick house rules. So we have you all on mute, but we really encourage you to ask questions. So in the bottom of your Zoom window, you should see a Q&A button. So please pop your questions in there. If the question that you're keen to get an answer to has already been asked, please do make use of the upvote function and we will prioritise the questions that have the most upvotes. We're aiming to leave around 15 to 20 minutes at the end of the hour for a discussion, and we'll definitely try and answer all the questions that we can then. So please do, if you can, stick around for the whole hour. But just in case you can't, we're going to record this session and we'll make it available on our website afterwards, and we'll share it with you guys and hopefully share the slides as well. So that's the admin out of the way. So hi everyone, I'm Rebecca. I'm the head of customer success here at Snowplow. And my team are comprised of customer success specialists, technical customer success managers and solutions architects. And we're just really focused on helping our Snowplow Insights customers get the most value they can out of Snowplow. And a lot of the time we really focus on the technical side of this and the strategic. So how to best design your tracking, how to think about your data modeling. We've actually just done a 4-part webinar series on that, which you should check out if you haven't seen. And that's obviously a really big part of getting value out of Snowplow, designing your data structures and consuming the data. However, there's a whole kind of other advisory piece that we're actually often asked to help our customers with. And that really focuses on building out the data team, whether that's thinking about where the resource should sit in a centralized or a decentralized model, thinking about who the next key hire into your data team should be so that you get the most value, and just generally thinking about scaling your data team with your organizational appetite to kind of build a culture of data. And one thing that we're often asked to do, and actually we love doing, is introducing our customers to each other and to talk about this journey they've been on, especially when they've kind of got insights they can share about different stages in the journey. And we find they're often very fruitful conversations. So luckily today, Mindy from Hudl, who's been working with Snowplow for a couple of years, has agreed to share her journey and the lessons learned. It's a super insightful presentation. So thank you very much, Mindy, for sharing that with us. So without further ado, I'll hand over to Mindy to talk through the journey, and I'm sure you'll have lots of excellent questions, which we will answer at the end.
Thank you, Rebecca. And everybody, I'm very excited to be here to tell you about how I grew Hudl's data team from 3 to 20 people over the last 5 years. Before we launch into that, first a little bit about Hudl. Hudl is a sports video sharing and analytics platform. We help coaches and athletes win by letting them upload game video, do breakdowns and analytics so they can identify their own tendencies, learn from coachable moments, and generate highlights. We work with 95% of US high schools and colleges, more than 100,000 teams across 30 sports globally, from some of the biggest professional clubs to grassroots youth teams. So all of that basically says we produce a lot of data. The team at Hudl that works to make sure this data is at the heart of decision science is decision science. We are a team of 4 data engineers, 1 analytics engineer, 8 data analysts, 4 data scientists, and 3 consumer insights researchers who are all united under one roof. I think that the key to our success is our diverse skill sets, united by our shared mission and mindset. I have the privilege of leading this team. This slide shows aspects of my background to give you context on me. As you will see, my approach to data is highly impacted by my background in engineering, product management, and consumer insights. Our agenda is, let's relive decision science's journey as a data team together to set the stage for learnings that will help you benefit from our experiences. We went through 3 distinct stages in our growth. As we talk about each, I will call out timelines to help you orient as to when each stage was happening. I will also try to touch on how our team was structured. our tech stack at the time, the type of analytics that we did, and the challenges that we faced as we cover each stage. I'll distill our team's learnings into themes that you can apply in the second half of the presentation. I'll tell you why you should prefer depth over breadth and delivering a slice of value when engaging with business partners. We'll address which roles you need to start up a new data team and what would trigger you to add new roles. I'll also give you tips on how to be a data partner instead of an order taker and show you the value of adding qualitative insights into your data practice. So be sure to stay tuned for that. But first, let's start at the beginning. It's 2015 and we just set out to build a data warehouse so we can help the business answer questions using data. During this phase, we started with 3 engineers who wanted to experiment with standing up data ingests and building a data warehouse. We found a couple of Hudlies with analytics backgrounds and started taking data requests from all areas of the business. During this stage, these 2 functions lived on separate teams, but they were united by the determination to put data at the forefront of decision-making at Hudl. This is our tech stack at the time. We built our data warehouse using Redshift and wrote our own ingests to bring data into the data warehouse. Our first analytics environment was Redash, a SQL editor-based BI tool. One major assumption we made when starting up the data practice was that everyone can learn to query data using SQL. At the time, Hudl was much smaller than it is now, had mainly engineers, so this assumption made sense. But as Hudl grew, it quickly became a deterrent to data usage. Product, marketing, sales, and other functions were forced to learn SQL in order to access data. This led to 2 problems. Some folks never felt comfortable pulling their own data. They waited in line for data analysts' help. And even though we grew the DA team from 2 to 5 people, there were still long breadlines of folks waiting for help, but then ultimately giving up. Another group learned SQL and went about confidently pulling their own data. But what they didn't realize was that even though they took 2 SQL classes, their SQL was still wrong, unfortunately. And on top of that, the data they used was also wrong because they didn't fully understand the nuances of that data. People got different answers depending on what data they used, but nothing alerted them to those pitfalls or stopped them from pulling and using the data to make decisions. This is what we started calling the illusion of competency. So let me show you what this looked like. Hudl is a SaaS business driven by product usage. Bree Campbell is an account manager at Hudl who wants to find teams that haven't been using Hudl so she can reach out to make sure that they are set up to get value out of Hudl. She can either wait in line for a data analyst to pull the data, or she can try to do it herself. And since season is starting, Bree can't afford to wait. So she tries to pull the data herself. She wants a list of American high school football teams that haven't exchanged film for 60 days or watched video for 30 days. This is really basic information to Bree's job, but getting it is prohibitively difficult. She has to write 149 lines of SQL, and every line is fraught with opportunities for error. This is why we said we have to democratize data, and this became a focus for us starting in 2017. Democratizing data is a buzzword, so let me tell you how we define it. To us, democratizing data means to provide independent access to trusted data. So it starts with trust. If people don't trust the data, they will not use it. During this stage, our focus shifted away from answering ad hoc questions to building out the most important domains of data to the company as curated data models that people can trust. We also invested in data quality. We worked with teams producing data to clean up source data problems rather than maintaining band-aids for them. And we improved our own development and testing practices, tooling, and environment. Once we had trusted data, we set out to enable self-service. We stopped expecting everyone to learn SQL and moved to a BI tool that enabled click-and-point data exploration. The result was an easier interface where people can confidently self-serve data that they can trust. So here we see Bree, our account manager, pulling the same list as in the previous video. Compared to the SQL she had to write before, click-and-point exploration makes it easier for Bree to do her job. To democratize data, we added Looker and DBT to our stack. We use dbt to model data and Looker as our click and point BI tool. Our team also evolved during this stage. We combined data analysts and data engineers into one team because we believe that teams working in the same value chain, so in this case, delivering insights through data, belong together. This move improved prioritization, communication, and alignment across our team. We added data scientists to our team because as Hudlies got hindsight and insight through reporting, they naturally wanted more foresight. And the first project we chose to tackle here was getting to predictors of renewal, which is core for Hudl to understand since we are a subscriptions-based business. Since the focus for most of the team shifted away from ad hoc analytics to creating curated data models, we funneled data requests that were not yet self-serviceable into a rotations-based analytics support function. Analytics support addresses quick turnaround requests like retention analysis for products and user identification for marketing campaigns. They help us keep a pulse on the data needs and trends across the company and illuminated which areas of data to target for self-service next. We also started embedding individual team members with business areas. Our goal was to shift away from being order takers to being business partners, and in order to do that, we had to start building business domain expertise and deeply understand the needs of our partners. We added consumer insights research because we wanted to understand the intentions behind customer behaviors and what to do about it. Consumer insights is a discipline that uses qualitative research like interviews and quantitative research like surveys to understand how the customer thinks and feels. They analyze human behavior to get to what our customers want and need and why they feel this way, what to do about it. Here, for example, our consumer insights team summarized research findings into an infographic to help Hudlies understand how athletic departments think about and consider the affordability of the athletic director package. This was to support Hudl's strategic push to win the school, meaning sell to the entire athletic department instead of to individual teams. During this phase in our growth, Hudl had grown from 300 to over 800 employees, acquired 4 companies, expanded globally. We were trying to keep up with Hudli's usage of data, but we quickly ran into a brick wall of scaling issues. Our ingests started out as MVPs to see if we could stand up a data warehouse, began to fail because they never anticipated the load that we ran into. All our data was in Redshift, and warehousing costs were growing beyond what we were comfortable spending. Democratizing data reduced breadlines, but building data models to enable that self-service was taking a really long time, and we didn't know how to move faster. The way we modeled data also made these models difficult to change and test. During this time, I literally felt like our world was being held up with duct tape and string, ready to crumble at any moment. Which brings me to the third stage in the evolution of our data team, scaling our capabilities. Let's start with how we scaled the team itself. So around this time, I kept wondering, is decision science right-sized for Hudl? To answer this question, we did industry research and learned that many organizations have a data team size that is around 3% of headquarters size. And Hudl has about 800 people in core corporate functions, so we were about 2.5%. We had approval to grow our team to 25 people this year, but I knew that kind of growth trajectory is difficult to sustain. How can we keep up with Hudl's data needs without having to scale linearly with company headcount? To me, it starts with removing inefficiencies in how we operate by getting the team structure and composition right. Our experience and industry resources both pointed to kind of an optimal ratio of 1 data engineer to 1 analytics engineer to support every 3 data scientists or data analysts. So we invested in the data engineering and analytics engineering functions. There are force multiplier roles that help us scale by making everyone else more efficient. And we were set to grow to 3 analytics engineers before COVID hit. But integrating even the first analytics engineer into our team pushed us to get clearer about the areas of ownership for data engineers, analytics engineers, and data analysts. This is an early diagram that we use to evolve our thinking around how each function contributes to the entire value chain of delivering insights through data. We were mapping out which role owned and did what, so we worked towards greater role clarity. The green boxes show that for us, the data engineer is all about ETL, getting data from source systems, and managing the data ecosystem. The pink boxes show that the analytics engineer makes analytics processes more efficient by establishing the right tools and patterns for the analytics team to use, so data analysts and data scientists can focus instead on delivering business solutions, which is shown in the blue. This looks nice and all mapped out, but I can assure you it is still a work in progress for us, and we're still learning. Also, to help our team scale, we expanded analytics support to dedicated instead of rotational staffing. This was a deliberate move to funnel one-off data requests to this team so we could free up everyone else to shift to deeper partnership work. This team served as our intake point for data requests. They triage requests, funnel work through work that required larger effort to teams within decision science, and addressed all of the remaining questions quickly through a ticketing system. We also expanded our data science team because we saw many opportunities to apply predictive analytics and machine learning to solve business problems. The more domains of data that we modeled, the more cleansed data we had to feed into this work, but we weren't realizing the full potential of this area, so we dedicated one of our managers to grow this data science practice. In the previous stage, we embedded lone analysts within business areas. We like the benefit of partnering closely with business areas to drive decisions and actions through our work, but embedding solo analysts left them feeling really isolated. This prompted us to move from embedding individuals to embedding teams, so we can align everything we did with the needs of our business partners and reduce that sense of isolation. I should note that embedding folks, the people that we embed, they are still decision science team members. They are assigned to basically deeply understand and serve a business unit, but they do not belong to that business unit. They maintain their objectivity. They're expected to be consultative partners, not simply order takers, much in the same way that you would see a Big Five strategy consultant doing. We'll talk more about how we do this later. Remember the duct tape and string that I felt was holding up our environment? Let's talk about how we dealt with that. So in 2019, we had been operating a data ecosystem for about 4 years. We had reached the scale and rate of growth that we knew was not sustainable if we did not take action. This slide lists some key parameters of the data ecosystem that we were operating in at the time. Our data warehouse was querying close to 200 terabytes of data and supporting an analytics workload of about 5,000 queries a day. This was exciting to us. I mean, we had achieved an impressive amount of growth since starting up our data practice. But what would happen if we kept growing at this rate? The red line in this chart forecasted unbounded exponential growth in our data warehouse volume. The cost to keep up with that was just not palatable to us. And making this problem even worse, we were starting to ingest high volume streaming data from our Snowplow pipeline, which made it urgent that we find a way to scale. This is what our environment looked like at the time. We had more than 25 bespoke ingests feeding data into the data warehouse, which then fed our BI tools. The data warehouse was weighed down by all of our data. It served both analytics workloads from people modeling and querying data to ingest workloads that brought in data from source systems. Everyone shared the same bandwidth, so what one person did affected everybody else. We did not have any more bandwidth to give to high priority workloads that we wanted to have more bandwidth. We also had to pay the same amount for every piece of data in the data warehouse, regardless of its usefulness. Our solution to these problems was to migrate from a data warehouse-centric to a data lake-centric ecosystem. We reduced our data warehouse footprint by offloading data to the lake. We kept only high availability, low latency access data in the warehouse. And for us, this meant important data about Hudl's teams, schools, and subscriptions and their activities on Hudl. Moving lower value data to the lake improved our cost structure because we only paid warehouse premiums for the most important data. We also reduced our multi-tenant problem by migrating ingest workloads off the data warehouse and keeping only analytics workloads there. Before, we could only use our data in the data warehouse. After, we can fan out data from the lake to more downstream applications. We can set up a transactional pipeline to feed data back into the product or support different machine learning workflows. These downstream options took even more load off the data warehouse and unlocked more use cases for our data. Besides migrating to the lake, we also scaled our data ecosystem by rewriting our ingests using industry standard tools and reusable patterns. We expected every new ingest that we wrote to improve quality, scalability, and reliability compared to what it was before. It had to be easier to iterate on, and we had to enable downstream discoverability by cataloging the data, all for the same cost as before. And it sounds impossible, but we've been able to achieve this through standardization. So this is a busy diagram. Don't worry about reading everything that's on it. It just shows that before, our ingests had no standardization. They were all bespoke. We solved the same problem in many ways using different tooling, as you can see from the tons of colors on this flowchart. Each color represents a different technology or data format in our old ingests. And having each ingest be a different pattern with its own tooling increases cognitive overhead and operability costs. Multiplied across 25 different source systems, and that's a lot of overhead. This picture shows what dealing with a crumbling infrastructure felt like for our data engineers. During the day, customers would complain to them about jobs that kept failing. They were forced to stop work while they reloaded data. Meanwhile, they had to post to a dozen public Slack channels that the data we have is wrong. And at night, they were woken up several times a week by legacy jobs. To scale some of these jobs required them to remember a dozen steps and to execute them in a precise sequence or risk significant data loss. This was the data engineering team working all through Easter Sunday because they finally got a chance to do new development, but they ran into unforeseen fires because there was no workload separation or codified infrastructure or CI/CD in our immature environments at the time. The human cost was our biggest motivator to change. Our change began with re-architecting ingests to follow a standard pattern, as you can see from the process flow at the top of this diagram. We deployed vendor solutions where possible to minimize the number of ingests that we had to write, and where we had to create custom pipelines. We applied the same patterns and tooling to lower cognitive overhead and operating costs. As we migrated ingests to this new architecture, we also put an emphasis on building better capabilities. So improving validation, enabling data cataloging, making all ingests lake first. The biggest benefit was a data engineering team that could apply their talents innovating for the future, instead of being dragged down by the burdens of the past. As Addison, one of our data engineers, describes here, their efforts really replaced the duct tape and string with solid scaffolding for the future. These are the industry standard tools that played a role in scaling up our data ingests. As I mentioned earlier, starting in 2017, we began modeling data for self-service, but the way we modeled that data was not scalable. When we worked in ad hoc analytics, we answered isolated questions by creating single-purpose data sets. They were overlapping, conflicting, not optimized, difficult to test and maintain because they didn't have any shared foundations. In the last few years, we've made a conscious move towards unified analytics, where we built shared foundational data assets designed to enable cross-cutting analytics using shared business constructs. So let's see what this looks like in practice. This diagram shows that when we were doing ad hoc analytics, we created a distinct data set for each question that we were trying to answer, represented by the blue boxes. We didn't think about making these data sets reusable because we were only trying to answer that specific question. We also represented Hudl's core business constructs differently for each question. So in the three blue boxes, you'll see slightly different versions of teams, activities, and subscriptions data. This contributes to disunified analytics because people get different answers depending on how they looked at the data. There was also no standardization around these constructs that are really core to understanding Hudl's business. We tried to stand up common definitions when we created models for self-service. But in order to build out everything that anyone needed around a domain of data, we ended up creating these massive denormalized tables with dozens of columns to accommodate specific aggregations that business users wanted. It's not surprising that everyone was afraid to iterate on these models. Nobody quite understood all the logic within them. Changes had unintended side effects, and the true grains of these data sets were obscured by layers of complexity, making them difficult to test and maintain. We began re-architecting our data models using the same engineering principles behind our ingests: abstraction and reusability to enable scalability. Our analytics engineer actually led the charge on this movement. So here you see the yellow boxes show that we now represent standard business constructs, such as teams, users, activities, using facts and dimensions. We can combine these facts and dimensions in different ways to deliver insights, as shown in the blue boxes, and still have unified analytics because they're pulling from standardized business concepts. The smaller modular intermediate tables in yellow were also easier to maintain and test. To wrap up this section, one of our team's learnings is that we should have put more energy into planning for scaling from the start. We should not have waited until we ran into a brick wall to take action. We're now on a better trajectory. I don't feel like we're held together by duct tape and string anymore, but we definitely paid the price for thinking about scaling too late in the substantial effort that it took to get here. One of the most important lessons you can take away from our experience is to ask yourself how your system will scale before you start building, and then to keep that question in the forefront as you operate. Let's talk about some other things that we learned that can benefit you. We have learned to prefer depth over breadth. So we started our data practice by hanging up our shingles, inviting anybody with a question to ask us for help. This gave us visibility into the extent of data needs across the company, but it didn't enable us to go deeply enough with any one business area to move the needle. Our focus was scattered by trying to help everyone a little, so we couldn't help anyone a lot. In retrospect, if we could do it all over again, I would find one business area to partner with so we can wrap our minds around their problems and demonstrate early wins by solving those problems. And the best place to start, in my opinion, is an area that is spearheading a major company goal that can act on the data right away. This speeds up your learning by getting insights to market quickly. It allows you to demonstrate early wins to generate momentum for more partnerships and investment in your team. Our team has also learned to prefer a vertical to a horizontal approach. So what do I mean by that? The horizontal approach is, let's ingest all the data from multiple data sources into the lake so we can do things with it. And then let's model it all and try to provide as much self-service reporting as possible on top of that data. Because we're tied up ingesting and modeling data, we usually don't have time to provide deeper insights or analysis or predictions. The problem with the horizontal approach is you never get beyond ingesting, curating, and cleansing data. And if you're like us, your data is constantly changing. There's always something in the bottom two layers to keep you busy. So if you have to work these two layers down to nothing before you walk up the data maturity curve, then three things will end up happening. You will likely start doing work of diminishing returns. You will never mature beyond addressing basic needs, and your team will be frustrated and capped in their growth and development. Our team learned this the hard way. So we've moved to a slice of value vertical approach. Similar to how we can choose to move the needle with one business partner instead of helping everyone a little, we can take one slice of value, start with the business outcome, and work backwards to implementation. Because the key to a small data team survival is demonstrating value quickly. Choose the slice that solves the biggest problems for the company. Ingest and model only the data necessary to solve that business problem, and then go as far up that slice of value as possible. At Hudl, one of the highest value verticals we can tackle is to help the organization win the school. As I mentioned before, Hudl is shifting from selling to individual teams to an enterprise model of selling to a whole school. Our high-value problem, therefore, is how do we get more existing customers to upgrade to the new full school package? To support this data outcome, or this business outcome, we need subscriptions, activity, and team data. We start by only ingesting that data. Next, we model that data so that we can report on which schools have upgraded, which haven't, and their usage profile. But we don't stop there. With the same data, we can tell product which features are heavily used by teams before they upgrade. We can interview schools to understand what plays into their upgrade decisions. We can go farther by telling leaders what factors are statistically predictive of whether a school will upgrade. We can also guide marketing and sales outreach efforts by assigning each school a probability of upgrading. We can go as far up the vertical as possible to deliver on that slice of value. And when it comes time to select the next data set to ingest or model, we can choose based on what that data adds to existing slices and what new slices it unlocks. This is what I mean by preferring a vertical to a horizontal approach. Let's turn our focus now to what have we learned from growing decision science that can inform your efforts to start up a new team. What roles should be in it? In what order should more specialized roles be added? We'll try to go through that. Most new data teams start with a data analyst or data scientist, and this may be your situation, depending on the focus of the team. If this is your situation, you will likely be looking for a full stack data analyst or scientist who can take on some data engineering, especially with the help of tools. This is increasingly possible because the ingest tooling space has really matured. You would add a data engineer if you have a data source that is not supported by an ingest tool and you need to build custom ingests, machine learning pipelines, or pipelines to integrate data back into the product for commercializing on data. You would also add a data engineer if you have data that requires special transformations that are not supported out of the box by ingest tools, or if you actually reach a scale where a tool-based approach is more costly than a do-it-yourself model. You would add an analytics engineer when you need dedicated effort to making your data architecture and infrastructure scalable. My learning on decision science is that we waited too long. I would recommend that this be one of the first few roles you hire because analysts and data scientists are typically not engineers. It takes an engineering mindset to think about evolving platforms and data architecture. And this is critical to get right from the beginning because it sets the stage for effortless instead of painful growth. You would add a consumer insights researcher when you want to go beyond describing and predicting to explain why and what to do about it. Rarely do I see qualitative data roles represented on data teams, but combining qualitative with quantitative has been a core part of our team's success that I'm going to share an example later of why this is a valuable combination. If you do decide to start with a full stack person, recognize up front that it will be difficult to find someone who wants to ingest their own data, set up their own analytics pipeline, design their own data architecture, partner with the business, provide reporting insights and predictions on top of all that. And even if you do find that person, it can be a gamble. We have lost data scientists who had to play a jack of all trades role in the early days of our team's evolution, and their morale suffered because they didn't get to use their specialized skill set. So you need to make sure that you find someone who is open-minded and willing to do a lot of different things. You'll also need to keep in mind that as the team grows, you will ultimately need to trade off focus and specialization. So just because someone can do everything doesn't mean that they should do everything. What is the best use of their time? And as you grow, at some point, you will also wonder, is a generalist good enough? Or are we at a point where we need the dedicated expertise and focus of a specialist? Whether you go with generalists or specialists, you should push them to use industry standard tools and building blocks. This is so important that I want to call it out as a key learning. Our team has learned to avoid reinventing the wheel. we rely on industry standard tools and building blocks to speed our time to market, free us up to do higher value things whenever we can. This has been key to our ability to scale. You will always have team members that want to create everything from scratch because doing that is fun. But what it results in is higher than necessary operational overhead. Not everyone who wants to create from scratch also wants to maintain what they created or harden it to scale because they would rather move on and create the next thing. Eventually, the accumulated operational burden of the things that are created but not hardened will become a crumbling foundation, and you will feel like your ecosystem is held up by duct tape and string. I have firsthand experience of this, so my advice is prioritize building with what's available and differentiate only when absolutely needed. Then make sure you're staffed to support what you build. Another thing our team has had to figure out is how to do data governance in a decentralized organization. Hudl is a decentralized organization with autonomous product teams. So unlike traditional organizations where there are committees that make the rules about data and no one can violate those rules because data is locked down, operating in our environment has taught us to codify governance. At Hudl, there are no limits on who can produce and use data. So we have learned to rely on systems instead of people as much as possible to enforce data governance. For example, we used to train all new hires not to select star from logs, which is a massive unstructured table of user activities when they're querying the data warehouse. And the reason for this is because it impacts performance for everybody else, since it takes so much bandwidth to query logs. So think about how unscalable that is. If we miss training just one person, or if one person forgets, in a shared compute environment, everyone is going to suffer. The way that we codify governance around this is by enforcing workload management rules that stop long-running queries in Redshift so they can't consume excessive bandwidth. This is engineering in fault tolerance as a systemic solution to a collective action problem. To take that up a level, instead of constantly educating people on what to do, counting on them to remember to do it, we choose to rely on systems to enforce the right behaviors. And let's talk about handling unstructured plain text user activity logging. So if you have this kind of data, you feel my pain. Logs come in non-standard formats, you have deregex, they're missing key contexts, they can change without warning. The developers producing the data are not even aware of the downstream impacts they are having. But data people are mad at developers for messing up analytics. The solution isn't to gate every PR before it can be merged. In companies of any size, like especially ours, that isn't doable. The solution is to migrate user activity tracking to a system that enforces schema definitions up front, schema validation on ingest, and schema versioning along with changes kicking off a review process. This is what we use the Snowplow pipeline for, because we believe that codified governance is governance that can scale even in the most decentralized organizations. Another area of learning for decision science has been how to evolve away from being order takers to being consultative business partners. The consultative side of analytics can be challenging, especially for technologists who find working with end customers to be difficult. So what's our approach? We start by saying, when a customer asks us to build them a dashboard or query or you name it, we don't take that as a given. Instead, we work to understand what their need is so we can apply our own judgment and creativity on how best to meet that need. So remember Bree, our account manager from earlier? Well, Bree really digs Looker now, and she wants us to build her a dashboard that puts all of the data for her accounts at her fingertips so she doesn't have to go hunt for information when she's deciding which accounts to call. We can build Bree exactly what she asked for, a big dashboard with all the information she wants, but the problem is this dashboard has so much information on it that it's overload, and it slows Bree down rather than speeds her up. She has to separate the data that matters from the data that doesn't matter when deciding whom to call. So let's take the guesswork out for Bree by building a predictive model and then giving Bree a dashboard of only the activities that we know are statistically predictive of renewal. But why stop there? Instead of a dashboard, we can give Bree a prioritized list of accounts to call based on renewal predictions or even algorithms used by other successful account managers. Delivering insights this way makes it easy to iterate on the algorithm under the hood to find what works best. We can even designate a portion of that call list. So for example, customers likely to renew anyway for automated outreach. So Bree doesn't even have to make a call, saving her even more time. This example shows that we can solve problems in smart ways that our customers don't realize are possible, and they don't know what to ask for, but only if we figure out what they need first and not just build what they request. So we've delivered the call list for Bree. Now what? How do we measure success? Our team measures success not by what we produce, which is our output, but by what outcomes our business partners are able to achieve using what we produced. We call this going all the way to the right. And on the next slide, you'll see what I mean. So we built the call list for Bree. We've set up automated outreach for accounts that are likely to renew without intervention. That's our output. That's what we have delivered. But that's just the beginning. We want to know if Bree is actually getting use out of the call lists and if it's saving her time. So we push ourselves to use data to measure the adoption of our data products. We also reject the mindset that all we can do is deliver the goods, whether someone uses it is outside of our control. Because we believe if Bree isn't using the call list, it's our job to find out why. So if the data's wrong, we have to fix that. And if the list is hard to use, then it's up to us to improve its usability. Besides helping Bree, we want to build a pathway that gets analytics and insights to the edge, where it can impact day-to-day operations. So we're not just building this for Bree, there's something in it for us too, and we have just as much stake in seeing it succeed as she does. Let's say that we ironed out the kinks and Bree is now using the call list happily. We don't declare victory there. If she's using it, but renewals are not increasing, then we have a problem and we need to go back to the drawing board and ask why. Are the predictions incorrect? Is the underlying algorithm or delivery mechanism flawed? Are there seasonality effects obscuring measurement? Similarly, we have to make sure that offloading accounts to low touch does not hurt renewal on those accounts. Ultimately, if we are successful with Bree, we will have learnings that we can apply to improve the company's bottom line and make all account managers more scalable through automation and prescriptive analytics. We can celebrate wins along the way, but we don't stop short of the business outcomes that we are driving towards because we put our energy and time into building this thing, and we want to get full return on our investment. That's what we mean by going all the way to the right. Finally, let's talk about why you should consider adding a consumer insights research function to your data team to help you harness the combined power of qualitative and quantitative data. Most data teams only deal with quantitative data. However, quantitative data alone does not tell the whole story. So let's walk through an example. In one market, Hudl has achieved a 98% renewal rate. It's easy to assume that this means 98% of Hudl customers in that market love using Hudl. Turns out that's not the case. Through qualitative research, we learned that 13% of the customers in that market have low repurchase intention, meaning they are reluctant purchasers of Hudl. They would switch away if there was a viable competitor. This is a concerning finding, but it's not evident from looking at renewal data alone. Furthermore, qualitative research tells us that satisfaction with add-on products in this specific market is what's impacting repurchase intention. Satisfaction with add-ons A and B is high. Satisfaction with add-on C is low. The insight here is that we can increase repurchase intention and create a wider moat against competitive pressure by improving the customer experience with add-on C. That's what I mean by combining quantitative and qualitative data to tell the whole story. To end this presentation, I want to show you the smart, hardworking people in decision science that I have had the privilege of serving. They were very excited that I would be sharing our story with you today and contributed in many ways to this presentation. And please reach out to me on LinkedIn if you would like to continue the conversation. I always look forward to connecting with and learning from you.
Awesome. Thank you, Mindy. I mean, I have to say that's one of the most insightful presentations I've ever seen, kind of really taking the journey of the data team and bringing it to light with lots of actionable insights, I think. And we've definitely got quite a few questions, so I'm gonna do my best to get through the ones we can. But like a super topical question, and I know something that we at Snowplow get asked about quite frequently. Just if you could expand a little further on the distinction between a data engineer and an analytics engineer, that would be really helpful.
Sure thing. Yep. So at least for us, data engineers are all about the ETL, so getting data from source systems, managing the lake architecture, and getting ingests into the lake, while the analytics engineer is more focused on making data analysts and analytics processes more efficient, so establishing the right tools for the DA team. Historically, our data engineers actually did all of that. And in a team where you don't have analytics engineers, you'll probably rely on your data engineers to do your DBT rollouts or whatever else you need to do for the analytics platform. But it's hard to have competing priorities. And our data engineers were having to trade off, like, do I prioritize stabilizing and ingest, or do I prioritize making DAs more efficient? And we just didn't want them to have to make those kind of trade-offs. So we brought this role in and made it the focus of the analytics engineer. And this also frees up your data analysts and your data scientists to really focus on partnering with the business, understanding their problems, rather than worrying about exactly how do I model the data, because your analytics engineer provides consistency and sound practices and patterns, and will teach your analysts and your data scientists how to model for sustainability and scalability in their growth. So it's also a force multiplier function for us because it offloads work and makes everyone more efficient.
Yeah, I totally agree. I think a lot of people are thinking about kind of hiring an analytics engineer at the moment. So I'm sure that will help the business case. And I guess a big part of obviously scaling your team is all around, you know, finding and hiring the right people with the right skill sets for your team. And do you have any insights you can share around how Hudl approached that?
Yeah, so I have, even since the beginning of our team, really made it a big priority for myself to make sure that we're putting people in the right positions to really activate on the value that they can deliver. And hiring is something that I found is not easy to offload. And we need to fully understand who we need, why we need them, and where, and drive that recruiting effort. I now rely on a lot on our analytics managers and our data engineering managers and data science managers. But in the beginning, I focused a lot on hiring. And the things that I look for are people who are good thinkers and problem solvers. The reason I look for that is most technical backgrounds you can train people on technologies, but I want diversity of experiences that contribute to their thinking and their ability to think expansively. And I also want to look for strengths in places where we have been weak historically, just so we are rounding out the team with every new hire being the exact thing that we needed at that point in time in our growth.
Great, that makes lots of sense, and I completely agree with you on the tooling side. That's definitely how I think we like to hire at Snowplow as well. So I think, Mindy, actually a question that probably goes back quite early to that journey that you were talking about, around like doing kind of ad hoc analysis versus kind of building out a structural process to think about answering a business question. Could you share perhaps like how you can make that distinction, or some of the things that are useful to think about when performing ad hoc analysis?
Yeah, so in ad hoc analysis, which is mainly still the focus of our analytics support team, the goal is really to broadly understand the needs of our business partners and to figure out how to quickly solve those needs, right? So if you're really working in kind of an ad hoc analytics world, it's request comes in, request goes out as quickly as possible so that there aren't long breadlines. What we look for in doing this is really what might be those opportunities to build deeper partnerships, because likely you will not want to remain in the world of ad hoc analytics forever. And so you could start to see trends, and these are folks on the ground in the front lines of data usage who see through all of the requests that are coming in, what are some patterns that are emerging. So when we were rolling out a new focus camera, which is a camera that is embedded in gyms or outdoors on fields that solve the problem of data of video capture for Hudl customers, we started seeing a lot of questions come in on focus and focus usage and focus inventory, et cetera. So this is a way to really understand where might be there deeper opportunities to partner. And right now, our analytics support team really handles a lot of one-off quick turnaround requests. The other thing that I've noticed is that among our team, there are folks that gravitate towards that work and there are folks that don't. So there are some folks that want kind of the instant gratification of solving a business problem and having someone say, high five, thank you for doing that. And then there are folks that are like, I really want to work on something deeply for several weeks straight and I don't want to be constantly interrupted. So if you're doing ad hoc analytics, just notice which members of your team tend to gravitate towards that work and which ones don't. And in our case, we now use ad hoc analytics through analytics support as a filtering function. So they are supposed to protect everybody else by letting everyone else focus. And then you notice people who don't want to be protected, like they're focused, they jump into the Slack channel and answer questions anyway. So just be aware of the type of folks you have on your team and their preferences in terms of figuring out who does best in what kind of analytics.
That makes sense. And I think an interesting question has just come in. So obviously we find ourselves in slightly different times and circumstances now, but kind of thinking about the journey you've been on, how did you go about building out the business case for scaling the data team and communicating that with the business?
Yeah, so I think the most important part of this is for leaders of a data team to really know the business and to understand what are the most important business outcomes. Then, and only then, can we set up our analysts and our data scientists for success in tackling those outcomes. So we'll find those high value outcomes where we know if we were to do well, we can hit it out of the park. And then we make sure that we set up folks for success so that they can shine. And when they do shine, we capitalize on those opportunities by making sure that the people they delivered for are speaking up in front of the company and talking about the value that was delivered for them. This is what generates the desire of the company to reinvest and invest more resources in decision science. So I think the most important thing to starting up a small data team is get to those noticeable, decisive wins quickly. Find those opportunities. And the only way you can do that is if you really understood the needs of your business and you know who can drive what outcomes with data.
I totally agree. I totally agree. An interesting question here as well around like the role of perhaps like the analytics translator, which I think we're seeing emerge a little, or kind of a business analytics partner. Would you see them as fitting, I guess, into the data team and that kind of as part of that consumer insights function, or would you see them as kind of perhaps more embedded with business teams?
We kind of expect everybody on the data team to be willing to be an analytics business partner. So we tend to hire for this skill set, and we don't hire technologists that only want to do technology because they will struggle here. So we tap into what's in it for them. Most people don't want to produce something that doesn't get used. So we solve for good needs, then they will get used and there will be return on investment. And we always hire for analysts that want to be world-class. Anybody can analyze, anybody can produce predictive models, but to be able to do that and partner with the business gives anybody an edge. And so we really capitalize on that aspect in our recruiting and get people who are motivated to be world-class. And then we go about making it possible by expecting them to answer questions about strategic intentions and struggles of the business areas where they're embedded. We limit their focus so they're working with one business area, and we make sure that they really understand the strategic goals and the struggles of that business area. We will ask questions like, what is the business need for this thing that you want to do? And what will this enable the business to achieve? Some team members are more skilled at this than others, so everybody has something to learn here. And we also ask, why is this the most valuable thing that you can be working on for this business unit? And we check with the business to see if they agree and to see if there's a disconnect. So this is really something that we consider to be core to everybody's job and not a specialist on our team. And it could be organized differently on other teams.
Again, yeah, I totally agree with your answer there, Mindy. And I'm really sorry. We've got some absolutely great questions that I'd love to be able to ask, but I'm conscious that people might have meetings to run to and keen to wrap up on time. So a massive thank you to Mindy for sharing your insights. Like, I've learned lots of things. I'm sure the rest of the attendees have as well. So the next in our Doing Data Right series is Identity Resolution in a Privacy Conscious World, the Impact of Web Browser Privacy Updates. So a little less on the people side and a little bit more on the implementation side, but should be some really, really great insights. If you'd like to sign up to that, you can head to our website. And if you'd like to learn more about Snowplow, you can also head to our website. So yeah, once again, thank you, Mindy. Thank you all of you for coming and listening, and I hope you've learned some things.
Thank you.
Bye.